Hello everyone, and welcome. Have you ever wondered what makes plastics so useful and versatile? From the water bottle in your hand to the parts in your car, materials called polymers are all around us. Polymers are simply giant molecules, like incredibly long chains made of smaller, repeating links called monomers. Today, we're going to explore the amazing properties that give these materials their unique and useful characteristics. First, let's talk about chain length, also known as molecular weight. Imagine a single, short thread. It's easy to break. Now, picture thousands of long threads tangled together into a thick rope. That rope is incredibly strong. It's the same with polymers. Longer polymer chains create more entanglements and attractions between them, making the final material stronger, tougher, and more resistant to heat. Next up is the internal structure. Polymer chains can be arranged in two main ways. Sometimes they are neatly packed in an organized, ordered pattern, which we call a crystalline structure. These crystalline regions make a polymer strong, rigid, and often opaque. Other times, the chains are all jumbled up like a bowl of spaghetti. This is an amorphous structure. Amorphous regions make a polymer more flexible and are often transparent. Most common polymers are actually semicrystalline, meaning they have a mix of both ordered and disordered regions. How do polymers react to heat? This brings us to their thermal properties. For amorphous polymers, there is a critical temperature called the glass transition temperature, TG. Below this temperature, the polymer is hard and brittle like glass, but above it, it becomes soft and rubbery. For crystalline polymers, we have a melting temperature, TM, which is the point where the ordered structures melt and the polymer becomes a liquid. This leads to two major polymer families, thermoplastics and thermosets. Thermoplastics, like the plastic in a milk jug, can be melted and reshaped again and again. Thermosets, like the epoxy and strong glue, undergo a chemical change when heated and are set permanently. They cannot be remelted. Of course, we must also consider mechanical properties, which describe how polymers respond to force. Tensile strength tells us how much you can pull on a polymer before it snaps. Elasticity is the ability to stretch and bounce back to its original shape, like a rubber band. Hardness measures its resistance to scratches and dents. These properties are why some polymers are used for strong car bumpers while others are used for flexible phone cases. Finally, many polymers have excellent chemical resistance, meaning they don't react with acids, bases, or oils, which is why we store cleaning supplies in plastic containers. They are also fantastic electrical and thermal insulators, which is why electrical wires are coated in plastic and cooking pan handles are made from polymers to protect you from heat. Thank you so much for watching. If you found this video helpful and learned something new, please give it a thumbs up, subscribe to the channel for more science content, and hit that notification bell so you never miss an upload. Your support helps us create more videos like this. See you in the next one.